now let's start our today topic: interfaces, lambdas, and inner classes. So basically the most important topic I want to share with you is interfaces. And we will slightly touch also in other topics too. So what is interface? Let me tell you that in general, this is kind of the same as abstract class. Let's pay attention to this syntax. What the difference? Okay, we put interface here. When we create class, what do we put here?
Well, some current attributes.
No, I mean in this just
Abstract. Okay.
abstract class. So just class. Here we put interface. This is the difference. And then we just have some methods. Okay, by default they all public. We could have default implementation of the method. I will tell you about it. But in general, let's consider interfaces. So big why. Why do we really need interfaces if we already have abstract classes? If we already could model some entity with future behavior, with abstract methods, and now we have interfaces which creates the same functionality as abstract classes. So the most important question, why do we have interfaces? And first answer to this question related to such concept as multiple inheritance. Let's think about that. What do we mean by that? For example, we have bicycle, but let me come to our initial example with animals. So I could have some abstract class animal, and then I could create another class which subclass this animal class. The question is, would I do this stuff? I don't know, dog, defender, let's say, security. So for example, we have some class security, and that class means that we want to defend our property somehow, and we use sometimes dogs for that, right? Is it correct? That's correct. So this is real situation, the real world situation. So the question is, can we do this in Java? Can we have multiple parents in Java? I ask you.
Yes. Multiple parents for one class?
Yes.
No.
So it depends.
It depends. Yeah.
We actually can, but in another way, like one by one. A parent of a parent of a parent.
I think for one child.
Okay. How really?
But
You mean
it's not really the
we
case.
need to put animal like inherit security? Yeah, maybe.
But it's not really logically correct because not every animal likes security.
But that's not cool.
Exactly. As Lev started to say, we could do it, but in another, and I want to add language. We could do it in another language, but not in Java. And basically this is good news. So for example, in C++, we could inherit a class from multiple classes.
Yep.
And that brings a lot of mess. So that brings a lot of problems. We could inherit something like, let me say like this and like that, and inherit again like this and like that. And the question is regarding many problems. But even though, that much better from object-oriented perspective, I could say that to inherit just one parent, and if we want to have some additional functionality like security, we could aggregate that security. For example, why not to do this way? And we could create maybe even security dog. Okay, let's do full example of that. we have dog, then why not to extend dog with security dog and just aggregate some security stuff with just aggregation. So we have some I don't know, object of security, and we could use that object inside and encapsulate that functionality inside the dog. So I mean that for multiple inheritance, basically aggregation is a better way to make things. So another, I don't want to bother you with examples, but I already started, so let me show you. Another typical example, we could have array of strings. String collection, let's say. We created this by ourselves, array list under the hood. Maybe we could manipulate with some strings, just on the basis of just strings. But later we see, oh, in our user interface, we could have this text area. And maybe we want to inherit in that text area this string collection and manipulate that somehow. So this is not very good way to do things. And if we really want to inherit something, we should be sure that it is a relation. Not something, this is just strings, and then something happened, just absolute another idea, you know. So in these cases, why not to use not inheritance, but again aggregation or composition? We could have this, and that would be much more better than inheritance. So this is the philosophical question about multiple inheritance. But still, in some situations, we really need that multiple inheritance. In some situation, we would like to have this ability to inherit from multiple sources. And in this way, interfaces help us. Like in this example, let's jump into this example. We have bicycle class. Then we inherit from this bicycle class, and we call this class electric bike. And this electric bike extends bicycle. Wonderful. But then, because of that electrical bike, we want to have some interface of charging the battery. And for devices which could be charged, we have interface rechargeable. And we have this method charge battery. So that's why we have not only superclass, but we also implement some interface. That's why it is basically almost multiple inheritance. So we have this electrical bike, or electrical, what we call it, bike, yeah. So, and we inherit from bike, but we also inherit or implement this interface, which is rechargeable.
Is implement the synonym of inherit?
Yes.
Kind
In this context, we could say yes, exactly. So if here we call extends, here we call implements. Like, I implement this interface. So why we use this implement? It is very, and let us come back to our general understanding of programming and abstractions and interfaces. I would like to ask you, what do you think? Why we call this idea of this another abstract class? Why we call it interface? What do you think? Why interface? Your ideas.
Well, I didn't see any properties, so maybe it's because I didn't see any properties there, so maybe it's because of that, because it's like it only has my guess.
I think.
But why
also-
interface?
Can interface have properties?
Yes.
Okay, it's all wrong.
Good question. Yeah, good logical like discussion.
Yeah.
What do you? How do you understand interface? What is interface? I mean, in general, philosophical.
Well, philosophical is something we like basically see on, for example, on our screen, or it like how something looks, for example.
Yeah. So our first reflection on word or term interface. This is user interface. This is how we interact with something. But you know, that interesting that user interface is a subclass of interface. So let's make it abstract. User interface. This is how we interact with system, how user interact with system through visual controls and so on. In that case, then what interface is? Nicole?
It's like a contract, an agreement that everything that is mentioned in the interface will 100% be there, and you can use it because you agreed on it on the class.
Okay, it's very hard explanation, like let's say it's correct of course, but very engineering explanation. Another thoughts, that's correct. Interface, what do you think, interface?
Well, okay, so if it's abstract, so we have user interface, for example, what else might we have?
Maybe just like interaction in general. So if it's user interface, so user interacts with the system. But in general, interface is like interaction, something with system.
This is key word, interaction with systems. Exactly. And as Mikola already said, this is contract. This is another word in engineering world which you will be familiar with. Another ideas? Okay, so we have component diagram in UML. We will not use this in this course, but let me show you that interface. This is a kind of connection to the system, connection through specific rules, and basically in engineering we call it interface. So this is our how we like this is something like that. How we work with the system. So this is our connection with the system. So let me come back to our first example. Do you remember this? What is that?
Space.
From electricity, like socket, reset. So this is what you said?
Face.
Our face of the
I thought it was like a button, like music.
yeah, I'm sorry, I'm not very good artist at this moment. By the way, I like drawing, but not this time. So this is socket. So do you know how socket looks like in UK, for example?
Yeah.
Yeah.
Something like that.
So
Do you know how it looks like in US?
Yeah.
Something like that, yes. And I don't know where is now. So basically, guys, all of that is what?
Different interfaces.
This is interfaces. This is just interfaces. How systems connect with each other. Device should have this kind of socket, Wilka, to use in the socket. And this is our interface, how we connect the systems. So my device should not know how this exactly, all this inner stuff encapsulated inside, how this logic done, which які автомати на щитку, which all this stuff. My device don't need to know that. All my device should know how to build this. This is all my device should know and should have. And this is basically interface. The same, absolutely the same here in programming. We could build complex system, and then, despite all this complexity, I propose simple interface, how to interact with my system. And interfaces, this is just the way how to propose a general interface for some complexity. So it could be that I want to have some, class, and this class has its own logic or hierarchy of inheritance, but then in some moment I want to implement some interface to allow other systems to interact with my class with this interface. Make sense? This is just very basic engineering concept, and interfaces help us to do that. So let me move then to show you how it works. So a little bit about syntax. First of all, implements, just please remember that. So if you want your class to implement some interface to propose socket for outer world, this class should use not extends but use implements. Then I should implement particular methods of my interface. The same like in abstract classes, just the same. So here I have charge battery, so that's why I implement or override basically this charge battery method. And that's it. So you already know that concepts from abstract classes.
Alright, so
Yes.
we extend classes and implement interfaces.
Exactly. Yes.
So we use interfaces not to mess with the other parents and child relations in the classes.
We could say so.
Because
But basically this is just multiple inheritance, I could say. This is somehow relation, this is somehow parent-child relation. But it is, when you see this picture, you understand that implements more appropriate term. But interfaces could be also inherited. So I could have basic interface, then I could inherit from this interface another interface, but we don't do that. In most cases, we just propose interface because we don't want to create another type of European socket. We just have this socket and that's it. And we implement that, and we could say implementation, or we could child parent. It looks like, but more implementation.
Basically, if we have like a complex class that is a child of a child of a child of a child, and we want just to add some simple like method to it that we have in other interfaces, so we add interface to that
Yeah.
child.
Yeah, you should feel the beauty of interfaces here, but in this. So let us just come back to this idea, engineering idea, and electricity. And for example, I have my second попытка, try to draw something. Maybe you will. Toaster, yeah, I did it. So I have some, complicated, some complex device, and I don't want to create like another device to propose use of that device in US, in UK, and in EU. All I need, maybe, of course, I'm not jumping to that 110 volts and 220 volts. It is not about electricity. Let's just abstractly think. So I need this, and then I will propose that, I will have also UK socket or вилка, я не знаю як. Plug, yeah. I just want to have this another plug. So all I do, I just implement another interface here, but my complex device stays the same. But I just add a little bit implementation for new stuff. Okay, so
Implementation that electrocutes you.
okay, so let's just
Can I
move
ask
forward.
one last question about this example that you're showing on the screen? Why
Yes,
do we need
please.
to use that interface if we anyway override the charge battery method?
The question, Ivan, one more time.
Why do we need to use interface rechargeable in this bicycle
Yeah, basically, yeah. So I want to continue this idea. So what is good here? That US, UK, EU sockets, they don't know what kind of device will be used for them, okay? They don't know, and they don't need to know that. That's why I take black box, which implements some of these interfaces, and I connect the systems. What that mean in code? I create variable of not bicycle, not electric bike, but I create rechargeable variable and here I put any implementation of this interface. This could be electric bike, this could be phone, this could be anything, but the type of that for socket want to know that this is rechargeable, not electric bike. Do you hear me? But just rechargeable. So I could create variables of this type, to charge them, to connect them to socket. And again, it is kind of polymorphism. I create rechargeable, but maybe will be a bicycle, it will be car, it will be phone, anything, any device. And then I plug this rechargeable to other system and connect them. Why? Because this interface is being kept. This interface is implemented. Let me show you an examples and that will become more understandable. So, electric bike. My bike, I create new electric bike. I use some inner methods. This is not very interesting for us, but then I call charge battery method. Charge battery method, let me remind you, charge battery method, this is method from interface, not from bicycle. Then another example. I create, as I just draw on the word, I create rechargeable and device, and I put electric bike into this device. Do you see the difference between this and this? Here, data type electric bike. Here, data type rechargeable.
Like electric bike is our parent? Yes.
Because electric bike is kind of parent or implementation of rechargeable. That's why it is correct to do this. Because it is a relation, right? Electric bike is rechargeable. Do you agree?
Oh, yeah.
Yeah? So that's why it is allowed to do this. So I create this, and I could call what? One method, because rechargeable has only one method, recharge battery, and that's it. But I can't do this, for example, because rechargeable have no this use motto. Something like that. Questions? Very similar to inheritance. Very similar. Okay, so let's jump into syntax. Just full syntax of interface. Public interface. So again, not class, but interface. Then the same. If you want to have constant or non-changeable variable, you could use it like this. Everything inside interface is public, because interface has no its own implementation. It could not be anything private. This public interface. Everything inside interface by default public. That's why we don't put here public, public, public. Everything is public already inside the interface. So I could have constant, for example, some like property, yeah. Then I could have abstract method, as we call it for abstract classes, but here it is just signature of the method. This is the most important part of the interface, and this is how we do. This stuff is additional. So we could basically have implemented methods in interface. This was added, by the way, later in Java syntax. So initial interfaces could have only abstract methods.
I guess it debuted sometime like Java 8 or something.
Yeah. So they just add default methods, and it's pretty good that we have that. And again, we could have static method also. Static method, and so the same, everything regarding static will work here. And when you want to implement interface, this is your syntax. You put not extends, but you put implements. Implements, rechargeable, and you override the same like in classes, you override specific method of the interface, okay? So basically like abstract classes. Okay,
Question?
yes,
Yes, question. I think the same
question.
The same question actually. I just don't seem to understand why do we need to make for example, charge method in rechargeable interface if we again just override the charge method in smartphone class.
Actually, make it simpler. Why do we write void charge in rechargeable if we can just write
Sometimes.
void charge in smartphone?
Without overriding, but just adding that functionality.
Yeah, just adding
Without
without-
overriding that.
Yeah, this is a good question. So we come back to this example, yeah? So why do we really need this construction if we could just throw it away and just to have this method here, right? This is your question. Good question. And we need this because we are in static and compiled languages, and everything should be checked on compile time. And if we need, for example, we have like electricity system, for example, and we will put object here, and inside the electricity system, in some inner method, we will call object and what? Charge. Yeah, or how we call it? Charge battery.
Assinto X.
Wow.
Wow.
We call charge battery. The question is, how we know that charge battery method is present in this object?
Because we have it in the class.
Yeah, because we just implemented that, yeah?
Yeah.
But that's mean that in this electricity system, we should, so the question, Ivan, the question next, what type of this object we should put in this signature of the method? What type should we
Type
put?
of the object.
Of the object type, data type.
Class.
Which class?
In our case, it's bicycle.
Electric bike.
Bicycle.
Electric bike.
We put electric bike here. And that makes sense. But next, we want to charge phone. Do we need to overload method of electricity and add another method and put another class here?
Yeah.
If then we want to add one more device,
So
how many methods we should create to serve every of devices? You see?
So I didn't catch up. So how do you connect phone?
Oh, can I answer? Try.
Yes.
Maybe it is all because of we try to make it easier. Instead of writing in every class that we try to charge battery, we just create an interface which we can implement in each child class, right?
Yes.
And instead of writing every time that we create a new method and overload it, we just create an okremy, a separate one, and just implement it from
But we
interface.
need to write it anyway, overwrite it every time we create a new class.
This is absolutely correct. We need to override. We need to add that implementation every time. That's correct. But another part of the system, this one, this signature, will not be electric bike, but be rechargeable. When we create electricity system, we don't need to know that would be toaster, that would be microwave, that would be fridge, that would be phone. We don't need to know that. We just create this socket and say any device with this interface I will accept. Any device I will accept. In programming, this method, electricity, I will accept any device which implement rechargeable. I don't need to know this is bike or car. I don't need to know that. And for the future, I could accept multiple different classes, different devices, even if they do not exist at this moment. Some programmer could create another class, and that class will just implement this interface. And my method, which I created 10 years ago, will still work. Do you see? Advantage. This method will work, and this method will not be coupled with some my socket work only for toasters. Without interface, I should create every additional socket for every toaster, every device.
And for example, if we made in interface rechargeable void charge battery some kind of a method that does something, not just void, like it doesn't have anything. If we make it do something, for example, the system out println something, and it will not be compatible for every device. Yes?
Discussion become complicated.
Because it's a
Like,
complicated.
yeah, for why we just create interface, but in our child class we continue overriding. Why do we override if we can just write it again?
Because for
again?
every class that would be different implementation. For
But we
every
always
class
use
that would be
same
just
interface.
different implementation. But contract or interface is the same. Signature of the method is the same. Implementation is different. But we could integrate these systems because we have the same interface. This system will be integrated. Without interface, we could not integrate that in universal way.
So I guess the question is, if they don't want to make like different implementations in different classes, they can make just default void and use it everywhere and like not rewrite it.
This question actually also touches like parent and child relations, because in parent we create some method and we override it in child, and why did we need to create it in parent if we anyways override it in child? So I guess
I can also try to explain.
the question is that we, without this interface, without the interface, we could make the whole task with the less actions.
Yeah, if the same implementation. But if the implementation will differ, then yeah, Lev, please.
I can. For now, this method charge battery from the interface looks simple because it has its own implementation. But what if we add some additional things into it? For example, for each kilowatt of energy, you will subtract some money from your bank account. And even if it is toaster or bicycle, they both have to subtract your money. So you don't implement it each time in overriding, like in toaster, in bicycle, but you add it into the interface, into the method charge battery. So you don't repeat yourself.
Yeah,
many times.
that makes sense. I understand that it is kind of complicated philosophical discussion, but let's move into our example of how we could implement and use that. So this first example, I will not comment. But I will just proclaim that we have, for example, comparable interface, and we could compare objects. How to compare animals? Maybe by name, maybe by weight,
My breed.
maybe by age. Programmer could decide, but Java collections could take that. If you have that implementation, Java collections could sort your objects in array list because of you implement this comparable interface. But let me show you another example. Event handling. So another very practical case. This is events. When we have some event and we want to delegate handling of that event to another object. So we have this. I will basically want to show you. Click handler up. Click up. So let me run it. So I have this application. Every of these controls are custom controls. So I have some rectangle and I have some label inside that. And I draw it in way I want to draw it. But then I could click on this custom object, and that custom object change its look. And you see I have here some reaction to my click. I click on object, but I changing something on parent application controls. How we do that? Because we create handlers of these clicks and we react to clicks on that object in main application. Let me show you how to do this. Where is my presentation? This is it. So let me show you diagram of this application. So we have, first of all, click up JavaFX application, and this JavaFX application aggregates several custom controls. So I have this custom control class, like it is aggregation relation. So I create that, and this custom control class, this have rectangle and label as is. But then custom control implements click handler. Implements this click handler, and I could put in this custom control separate handlers and react to that. Let me show you in code. First of all, click handler interface. What is click handler? Click handler is simply a function or method, or basically this is a class with a method, which have, guys, you will lost all the material. So this click handler has just handle method. So I have this custom control. When I click here with mouse, I should run this method, click handler handle method. This is it. This is idea how I want to implement this interface. When I implement click handler, that means that I could just run this function. Let me go further. Custom control class. What is custom control class? First of all, in this constructor, I just create this rectangle, put size, background color, label with text, and so on and so forth. Then, interesting part starts. I run in constructor this set on mouse clicked. Why I have this method? Because I extend pane, and pane has this set on mouse clicked method where I could put click handler also, but more in system way. What I do in this set on mouse click. So when I click on this pane, if it is pane, I could click on pane. When I click on this pane, I just check if click handler not null. What is click handler? Click handler, it is my private variable in custom control. I check if click handler exists, then I run this click handler. Click handler dot handle. This is it. What else do I have in custom control class? I have this method. This is part of this class, custom control. Set click handler. The same way as you set handlers for system controls. Now you create your custom control and you propose to receive, to accept custom handler of this interface. So you just put here click handler, which implements this interface, and you put this into private variable, which is here. And also we have just getter. This just continuation of this class for you to understand the syntax. This is continuation of custom control. So we have this method here. Okay. So I ask you a question. What set click handler accept as an argument?
Object,
Yeah, object of
click handler.
Class which implements click handler, to be precise. But basically this is data type of this interface. That's also correct answers. So I accept click handler here. Okay.
Yeah.
Let me ask another question. Where am I use this variable of click handler? Or before that, let me one more time make this checkpoint. What is click handler? This dot click handler. What that mean?
It is name of our class.
It's like a
Parameter.
property.
This is okay. Stop. Wait a minute. Parameter argument is here. Click handler. What is this dot click handler?
It's a click handler that is
It is the private click handler or the click handler.
This is property of our class here, right? Yes. Okay. And final question, where do I use this click handler?
In on mouse clicked.
I use it here, right? Okay. So I use here. And what is this? What this method means? What this code means? One more time. Someone else. Okay. Yeah, let's start and then someone complete your answer.
Okay, so set the mouse clicked. It accepts some similar style functional interface implemented to see what this custom control will do on the click.
Okay. Someone please continue
you-
the
can you-
explanation.
Can Mikola repeat it, please?
Sure. This function as a part of the pane, it sets some predetermined event handler as a functional interface here.
There is some function on this non-CGU.
Yes. Okay. So, and my question to you, one more question. When on this pane, user click on this pane, yes, we extend pane. So that's why custom control is a pane. Pane is something which we visualize in our application. And when I click on my pane, what will happen?
Something which
Event.
is in handler.
Okay, Sophia?
Just event handling.
Event handling. In which part of the code?
After that, set on mouse clicked.
So this part will be executed, right? Okay. So when I click to the pane, this part will be executed, and inside I just check if click handler is not null. If it is not null, then I what? Take click handler, and what this mean?
null and interface. It's not a
Member of click handler, yeah? I call member of click handler, which is handle. I call this method, right? Make sense?
Okay. What is E?
Event.
What is what?
Event.
E? Yeah, it is parameter of system event of pane. We don't use this parameter as you see here. We don't need event. We don't handle that additional information. Now, in my main application, what I do, let's discuss. First of all, I create my custom control, okay? I create it and I put it somewhere into my root or somewhere, and my pane been created. I call it my control, okay. Then, guys, what do you see here?
Lambda expression.
Yes, it is lambda expression. That's absolutely true. What the essence of this quote, of this lambda expression, what all of that means?
Not those just brackets.
It is lambda, no, syntax of lambda expression, right?
Lambda expression with no parameters. Okay? No parameters here. In our interface, we want to call method with no parameters.
So it's like when this event happens, our system prints control click.
Yeah, exactly. You're absolutely right. And this is just another way to do the same. This is just different variants of this way. Either lambda expressions or either anonymous class, which we should talk also.
Why don't we write like events, like again, when like control set click handler and open brackets event and system output event control click. Why can't we?
This is it. This is exactly what we do.
But we don't write e.
If
No e. Event.
event, because we decided that we don't need that. So we implemented this without e, and when we call it, as you see here,
Yes.
we call it without e. That's why we just don't need it. We decided, oh, I don't need this parameter here, because it is my implementation. This is my custom event handler. I want my custom event handler to be very simple, have no arguments. I decided that. That's why I call it without arguments. This is my right as a programmer. So, this syntax, this syntax, this syntax is just the same. All of that, just the same. This is equals. And this. So, this is just lambda expression you already know. Let me move forward. And basically app class in more details. So I create just root pane, no control selected, label, some current control name, some set font, make it bigger, and add children, add current control name. So just add this label. Next. I'm sorry. I have a meeting, but I have no time for that. And the most interesting part, how we add custom controls to our application. So we have just for loop here, okay? For loop for 7 elements, right? In this body of this loop, I create new custom control. So I put in constructor some label name and put this label here inside my constructor of custom control. Then I just position this. So I want it be positioned with this algorithm. So I put here, then here, then here. So every next element will be put here. And then this part is the most interesting. So custom controls set click handler. And in this click handler, I have this handler. When I click to this rectangle, my custom control, what I want to do. First, I want set style. So I make it red. This is my first action. Next, I take my current control name, which is label, and I put selected control and take this custom control get text. So this custom control get text. I get this control 1 text and put it here. Okay? Then, if current control, it is another variable in my application. I manage this variable by myself. If in current control, my previous current control, as I said, variable, if it is not null, that means that I already clicked some of these controls. If it is not null, then I just make light gray, like this control. I make again gray, because if I don't do that, every control will be red. When I clicked on every of that, they become all red. I don't want that. So that's why I take previous control and make it light gray again.
How do we know that the previous one will be light gray?
We set it light gray. We
Yes,
take previous and set it light
I'm
gray.
talking, for example, if we press on Control 3, how does it know that Control 2 needs to be light gray, not Control 1, not Control
Yeah,
3?
that's a good question. Because we manage this variable, current control, and this is how we manage it. At the end of this handler, we put into, this is kind of buffer. We put current control equals this control. I click here, and I put this variable into this buffer, the current control, and when I click to another, I will take this previous control and put light gray into previous control. And all of that controls I put into the pane, like add children. This is it. So this is the simple idea of how we handle custom events with our own interface. So we should create this interface to create it. Okay. Next, guys, we have not so much time now, so that's why I do it very quickly. I will not explain you another subject like inner classes, but very brief. In Java, it is possible to implement inner classes. I would ask you to read about that in our materials, because we will have simple questions, not complicated, not complex questions, but simple questions about inner classes in our exam. That's why you need to know that we could have inner class, like this is, I have class, and inside my class I create another class. Java have this wonderful opportunity. This is called inner class.
I'm gonna use this in production because we're making it obviously.
Yes. Then I could have static inner class. This is a type of inner class, but static inner class, which can access just static methods and members of our parent class.
So good question. I forgot what static is.
It is
It is
hard to explain in 10 seconds. This is what Vlad explained on.
Shame on you. Sorry.
The shortest answer, static members is members of the class, not of the objects. But to explain it further, just watch Vlad's explanations on 2 lectures ago. And local inner class, this is same like in other inner classes, but when I implement class inside the method, not just inside the class, but inside the method. This is local inner class. And anonymous class, which is kind of we saw in that the most complex Lambda expression that was anonymous class. So again, please learn it by yourself. A little bit elaborate on these topics to understand that in very general. But now I want you to do so I will put this presentation also to Canvas, but please read materials.